Hi, this is Ryan Shellhammer, and I'm going to be talking about my fifth and final new technologies. And this is kind of a simple one. It's a nice program that's been created by Biointeractives. It is really kind of a one-time use, but it's really good for teaching exponential and logistic growth in biology when we're talking about population dynamics. This is kind of a harder concept for kids to understand, is that populations don't grow exponentially, because they would grow forever. Whereas logistically, we incorporate something called carrying capacity, which hopefully everybody knows what carrying capacity is. It's the maximum number of individuals that can be supported by a population. So simply, it gives a good introduction to why we have population models, the importance of understanding how populations can grow and be limited, and then it even incorporates this mathematical part. A big push in our district right now is numeracy, which is understanding math at all levels and every class. So we're kind of working with the math department to integrate math into science, which math has always been important in science. It's been a part of my goal as an instructor to teach my biology kids how to use math, because they get in there and they're like, I don't know why I have to learn math. But math is still important in every aspect. So it gives you introductions to exponential growth, what an exponential model is. You can kind of use this maybe for zoology kids when we start talking about the ecological importance of certain organisms, but it tells you and breaks down what everything means. And once you finish that, you can start creating an exponential model. So you can change the number of individuals that it starts with. So if I start with 500 individuals, how quickly does a population grow? If I start with 0 individuals, it's obviously not going to grow. So you can set them through and tell them, set your beginning parameter at 0. Why does the population not grow? Now they have to analyze this. If I have 0 population, if I have 0 individuals starting, where am I going to get any other organisms? So then I can change the time and see where the population is at 10 years. And then it even has a play, so it plays it through. Gives you the slope, gives you lots of mathematical adherence. So we adhere to numeracy here. So again, if I change this, I can then again ask my kids to start at 30 and say at year 3, what is the population? So they just need to play it out or move it to year 3. They can type it in, and it'll tell them what the population is. So they can go over here and figure out, based on their scale, what the population is. Or they can just look right here, 252. And it gives you the slope. So if I continue it, I can have them stop at 5 years and ask them what the slope is. What's the difference at each intersect, or at each point? What is changing? Why is it growing faster here? And again, it's fun to kind of play with. And it even gives you a nice little density depiction down here in the bottom right. It also has a how-to bar. So 1 shows you the graph. 2, the parameters that can be changed. Settings. So even if I went back over here and changed the settings, I could change the minimum population to 0. I could change the time. I could make it go 100 years instead of just a lowly 10. So over time, once we get to 100 years, the population is huge, 6.8. So that one's really fun to play with. Now you can move on to a logistic, and then they read and learn about logistic growth and learn that it is dependent on carrying capacity, K. So once we incorporate carrying capacity, we can now look at what happens to our population. So again, it gives you the how to use. You can change everything. They're all similar to the exponential one. So this is where this K comes into play. You tell them, I could tell them set the carrying capacity to 0 and ask them why is there nothing? Why is there no individuals? Change it to 10, maybe 10 individuals, and don't change the carrying capacity. What happens at that point? Because now it's going to drop instead of stay normal. I have to change my y-axis. So again, if I change this initial number and make my carrying capacity a little bit higher, it's going to level out at 200. So I can show them this and they see how over 10 years the population is going to grow and then stabilize. And then you can go back to when we talked about the basics of logistics. We need to learn what R is. And they are able to go in and learn what R is, per capita growth rate. So these are where birth and death rates are located. So it just teaches them each different aspect of what makes an actual population limited, and then you can kind of start asking why. Why is there a carrying capacity? And then you can start talking about human population. Do we have a carrying capacity? You can do this website with a new worksheet that talks about the human population, and what they'll see is that humans are still growing exponentially, so we don't know if there is a carrying capacity yet. So it again is really good for introducing all of these things and then allowing them to see it graphically.